Well, hello, students and seekers of general truths. We now look at another feature of the robot car, which is the ability for it to turn and rotate. Now, what we discussed earlier, making the motor and making the wheel rotate 90 degrees is not the same thing as making the car actually rotate 90 degrees. So here we have a picture of a car, a robot car. And this is the I think the Vex V5 Clawbot. And this length right here is 12.8. And again, all units here are in inches. And the wheels here have a radius of 2 inches. So we could say that the diameter here is 4 inches. Okay. What will it take, or how much will this wheel have to spin in order for the car itself to rotate 90 degrees? Okay. And in this case, we're just going to have the right wheel spin. So to really understand how the motion works, we have to look at the bird's eye view of this car. All right, so I've drawn it out here, and basically this is what it's going to look like. This is the green squares here are the wheels. It has a bar going across, and this is serving as the axle for the front wheels. This is the axle for the back wheels. This is the brain, and back here, this is the back of the car, and this is where the arm attaches to it. Right? Now, when the right wheels is spinning, basically the left wheel right here is going to stay the same. So what ends up happening is that the robot starts to spin, right? This wheel here starts to spin, and the whole robot starts to rotate. It's going to rotate this way, okay? And it's just going to go all the way around. And as it spins, the robot car will, or this particular wheel here, will start to trace out a path. Right? It's going to trace out a path that looks something like this. And it's kind of like the wheel, I'm looking at just from this particular wheel here. That wheel is just going to keep on moving about around this path right here. Okay? And this circle, right, it's going to end up being a circle if it just continues to spin. And as it spins like that, we end up with a circle, and the radius of this circle is going to be the same length as the width of this car, right? So this car is really not capable. It's like you're taking this arm here and you're just spinning it all the way around. And again, this arm here is really not capable of bending or flexing. It's just going to stay, it's a solid piece of steel. So this path right here is going to be, or this radius right here is going to be 12.85 inches. Right? And if the car was to spin 360 degrees, so if the robot car rotates 360 degrees, then that means that the wheel here will have traveled a distance of the circumference of this circle. Okay, so that means the wheel traveled a distance of 2 pi times the radius of this circle, or 12.85. And again, this is in inches, so multiply this out. This will give me 25.7 pi inches. Okay. So that's how much the wheel traveled. Right? And in other words, that's how much it rotated. Now what we want to do is figure out, well, if that's how much it rotated for a 360 degree turn, then what would happen if the car was to rotate only 90 degrees? Okay, so if the robot car rotates just 90 degrees, then this wheel here would only go a quarter of the way. It would only go this far, about where you only have a 90-degree rotation there. So if the robot car rotates 90 degrees, then the wheel will travel 93/60ths, or 1/4 of this total distance. Okay. So if the car was to turn all the way around, it would have rotated 360 degrees, and that's how far that wheel would have moved. For a 90-degree rotation, well, it would move this much, but only 1/4 of that, or 90/60th of that. So we take 25.7 divided by 4, and we end up with 6.425 pi inches. Okay. But now we can get to the point where we can answer our question. If its wheel has a radius of 2 inches, how many revolutions does that wheel have to turn? Well, let's keep in mind once again that one revolution is the circumference of the wheel, right, of the wheel now. Okay, so one revolution is equal to 2 pi times the radius of the wheel, which is 2, which gives us 4 pi. Okay, so we need the distance traveled to be 6.25 pi inches, 6.425, excuse me. We need the distance the wheel traveled to be 6.425 pi inches, and we know that one revolution will produce 4 pi inches. Okay. So working out all of the unit analysis, the inches cancel out. You have 6.425 pi divided by 4 pi, and that will give us actually an exact value of 1.60625 revolutions. Okay? So if we want the car to make a 90-degree turn, then we want the wheel to travel a distance of 6.425 pi inches, and that means that the wheel must rotate 1.60625 revolutions. Okay, so this takes it's not vastly complex, but it does take a little bit of thinking to really work it through and come up with a sane, consistent answer. All right, so I'm going to end this video here. In the next video, we will talk about how do we generalize this process once again. As always, thank you for watching, and have a wonderful day.